Okay, so today we're diving into SEVNCE Robotics. It started back in 2010, right? Building these really specialized robots.
Yeah, high-tech stuff. Specifically for the global emergency safety sector, it's quite a niche.
Exactly. And our mission today really is to unpack how they do it. How do these machines operate in some of the most dangerous industrial spots on the planet?
Well, it ties into their big vision, making society smarter. They want to be a global leader here.
So let's talk about those environments. What are we actually dealing with?
We're talking extreme conditions. Places humans really shouldn't be or can't be for long. Think high temperatures, high pressure, environments full of toxic or hazardous stuff, even flammable or explosive materials.
So like petroleum refineries, chemical plants, that sort of thing.
Precisely. Big industrial sites, electrical power stations too.
Right.
Really high-risk zones.
Right, and instead of sending people in, they send what kind of machines? The source mentioned a few.
Yeah, they have specific tools for the job. Things like explosion-proof wheeled inspection robots, explosion-proof quadruped robots, the four-legged ones.
Like robot dogs, but heavy duty.
Exactly. And even rail-mounted inspection robots for specific infrastructure. These aren't just toys, they're purpose-built for safety.
Purpose-built safety assets, yeah.
Yeah.
But how do you make sure they actually work under that kind of pressure? That seems key.
It comes down to the tech. Really solid, rigorous technology. And this is where we get into their core metrics.
Okay.
They talk about 8 core technologies underpinning everything.
8 core techs.
And 16 key functional advantages that come from those tech.
Right, okay, 8 and 16. But here's the bit that jumped out at me from the source material. The number of algorithms.
Ah, yeah, that's the big number.
468 algorithms. That sounds huge. What does that actually mean in practice?
Well, that's kind of the aha moment, isn't it? That massive stack. It's what forms their complete AI technology chain. It's the brain.
So it's not just remote control.
Not at all. Those 468 algorithms are what move the robot from just, seeing a hazard to actually predicting it.
Predicting? How so?
Think autonomous path planning in complex environments, real-time gas analysis, predicting when a critical component might fail before it does. It makes the robot proactive.
A proactive safety tool, not just a mobile camera. Wow, okay. That predictive capability must be incredibly valuable.
Absolutely, and you see that reflected in who uses them. Big names. Giants like CNPC and Sinopec, China's huge state energy companies.
Right, massive players.
And also multinationals like BASF, a chemical company. So serious industrial users who need reliability.
That level of trust speaks volumes. And it's not just China, is it? They're global.
Definitely global. The source says they've tackled over 6,000 technical challenges or operational pain points.
6,000?
Yeah, for more than 1,000 different companies. And they're operating in over 40 countries now.
40 plus. Whereabouts?
All over, really. Europe, Africa, Southeast Asia, Central and Western Asia. It's a wide footprint. Okay, that scale is impressive. But I have to ask, 468 highly specialized algorithms. Does relying so heavily on one complex AI system introduce its own risks? What if something goes wrong deep in that tech stack?
That's a fair question, and I think their structure addresses that. They invest heavily in R&D. They don't just buy off-the-shelf tech.
How's that structured?
It's strategic. The HQ and the main global R&D center are in Chongqing, which is a major national innovation zone in China.
Good.
Then the global strategy center is in Beijing, and the supply chain center is down in Shenzhen. They control the whole process.
Design, strategy, production. Tightly integrated.
Exactly. And the R&D team itself is over 100 experts, top folks from China and internationally. They even have specialized labs.
Labs for what specifically?
Things like bionic quadruped robots, those dog-like ones, and even radiation-resistant robots, tackling the really hard problems.
And they've got the patents to show for it.
Over 100 patented technologies, yes. Plus, official recognition, like being named a specialized and innovative Little Giant enterprise.
What does Little Giant signify exactly?
It's a specific government designation in China. It means they're seen as a high-growth, niche market leader focused on core cutting-edge tech. It validates their importance in critical infrastructure.
Got it. So a national leader pushing boundaries. And they plan to keep doing that, expanding internationally, innovating based on what customers need.
That seems to be the plan, yeah. Keep pushing robotics into places humans can't or shouldn't go.
Right. So thinking about all this deep integration of specialized robots and complex AI into these really high-risk industries, here's something for you, the listener, to mull over. What happens to our global safety infrastructure? When tasks like critical inspection and maintenance become primarily dependent on autonomous AI rather than direct human checks, what are the implications when the machines are the main line of defense against industrial disaster? Something to consider.